Hello, today I want to talk about how to convert STL to voxel with Binvox. So in this video, I will cover what is the Binvox library, how to voxelize a single STL file with a Binvox, how to read Binvox file with Python, how to visualize Binvox file in Python, and then how to voxelize multiple STL files with Binvox. So let's start with what is Binvox library. So let's minimize this. Okay. So Binvox library is an application developed by I think Patrick Min, a graduate student at Princeton. It just voxelized 3D models. We will talk about STL, but the application itself can take several inputs, for example, OBJ, OFF, DXF, PLY, and obviously STL. And the output could be Binvox, Mira, Minecraft schematic, and other. So I use STL as input and Binvox as the output. So to start using Binvox, first based on your operating system, you have to download the the app. So here I use Windows. I just download this app, and then you go to your directory where you have your STL model, and then you copy the app in that directory. So, and then if you go to the command prompt, you can see whether the Binvox is here or not. Binvox. And yep, yeah, the app is here. So because I didn't write the accurate code, you just get the error and you get this information how this Binvox work. So the usage manual. So you have Binvox and you have D, and then here you know what D is specify voxel grid size. So you say I want to create a voxel and the grid size I want to be, for example, 32 by 32 by 32. And the T here, you can see that T, it is a specified of output or voxel file top. So we work with Binvox, but you can put Mira and Mesh or any other output that you want. And then you can specify the voxelization method. For example, C is here is a Z buffer based carving method. I use E exact voxelization, and then you direct the code to the file that you want to voxelize. And here we have an example at the end, binvox cd200t mira, and then the file is plain.wrl. So here to test it, I have a STL model. It's a 10 by 10 by 10 cube with a slot here, and then I want to voxelize this. So I go to command prompt. Yeah, I have already written code. Okay, use the code. I think this one doesn't work. Yes, I have to say in this directory go and voxelize the file. Okay, just you can hear you send done and the voxelization happen, and I have to have file here. So I because I had previously I had the file binvox file here, and I rerun the code. It gave me another file. Just add the index one. I delete it, so I have the model here. And that's it. If you just want to voxelize a file with Binvox, that's simply it. There's no much more to it. But if you want to quickly check your Binvox file and see whether it's okay or not, you can use for quick access, for quick visualization. I think the best thing is to use ViewVox, which is a app developed by the same developer. ViewVox, which is used for visualization. Again, you have to just download it and put it in the directory. I have it here. And then you just have to, the code is just ViewVox, ViewVox model dot Binvox. Okay, you can see this is our model. Let's compare it to the actual model. So this is what this one was. Oh, which one is better? None of them. Okay, this is our STL model, and this is our voxelize model. You can see that you are, when you voxelizing it, if you use a really low resolution, these details, you'll lose a lot of details. So you have to, if you want more details and a really exact representation in voxelization, you have to use higher resolution, which comes with a computational cost. But there are some alternative like a sparse voxel representation, which I uh, give a comprehensive discussion about that in my paper in a manufacturing feature classification problem. I compare the voxel and octree for a sparse voxel representation and show how a sparse voxel is better because you can have high resolution with much less computational demand compared to voxel. You can check my paper. I put the link in description. So let's get back to the tutorial. Where were we? Okay. I showed you if you want to just take a quick look at your voxel, you can just do that. And the other thing it would be, you have your model.Binvox. You want to import the information in a Python. So do some calculation or use it for other purposes. The first thing to do when you want to import it in Python, you have to download this library called Binvox RW. So there's a GitHub library for it. So you come to this GitHub and you just download this Binvox RW. There's no problem, but there's a small issue because this code is, I think, older and it uses NP boolean and NP integer, which is deprecated. So you have to change it to integer and boolean. So if you use this library and you get an error, don't worry, you have to just change that NP int and NP bool to int and bool. Or either you can use mine, which I already change those lines of codes. So you have this, you go to your Python, you just import this library, and then you import your model, which is we have it in model.binvox. We import it and we put it in the model parameter. So you can see after you import, you can check a lot of things. For example, model dimensions, which is 32 by 32 by 32, which is the one we specified. Model scale. This is because the voxel is normalized to 1 by 1 by 1 cube. You lose the scale, so you have the scale of your original STL model here. So if you want to scale it back, you know how to do it. And then translate is and also the voxel file is centered, and translate means you didn't need to translate the file from. So if your STL model is not centered, you have to translate it to centered. So yeah, if you do that, it just records what was the translation, and it just shows you here. We can go through an example where here the file was centered, so translation is 000, but we can go through one more example where we have a translation. So here I have a FreeCAD. I use FreeCAD. FreeCAD is really good application. It is open source and it's really good for writing macro. And here I just show one STL file, but in my work I had a data set of thousands of STL file, and FreeCAD is really good for writing a macro and then run it to create a multiple configuration of this STL model, which I will cover in my next video. So stay tuned to about that video. So here I just want to show you that. Let's go to the sketch, edit sketch. You can see that this square is not centered, so our model is not centered here. So if we export this model as STL, here you can go here, file, export, and use STL to export this file. You have your model here. I named model offset, and you can go to Python, import this model offset. Here the scale is 100 because it was 100 centimeter, so the unit is millimeter. And then the dimension is again 32. Oh yeah, I think I didn't do one part, which is after you export it as a STL, you have to go through the same process for this file to voxelize it as well. After you voxelize it, you come back to the Python. And then you can see that the model offset that translate is -30 -30, which is not 0. So that was about translation and what this number is. And then at the end, your voxel data is just a 3D matrix, which gives you where which voxel is filled and which voxel is empty. So it's just a 3D matrix with zeros and ones, true or false. So this would be your voxel data. And as you can see, it doesn't have dimension, so you have to doesn't have a scale, so that's why we record the scale, we record the translation, so we know how was our initial model in the size or translation of it. Okay, I think that's it, how to import the file. So let's go to the visualizing it. There are different methods, but in Python, I think the matplotlib is the best one. It gives you really good visually appealing voxels, but it's a bit slow. So you use voxels function to plot the voxels. You can define the face color, you can define the edge color, and you can, I think the alpha is either transparency or it's the thickness of the edge. You can check it, I think. So after you just plot it, this one is not that slow because the resolution is not that high. But if your resolution is high, this process take a lot of time because it has to plot all of these voxels one by one. Let's check what alpha was. Let's put it on 0.1. Rerun it. Yeah, alpha is transparency. Let's go back because this is not beautiful representation. And then if you want to rotate the file because the feature is in the other way, you can just use the numpy rotate to rotate it. Here I rotated twice along the X, Y, Z axis. And then we can just plot it. Again, you can see that it plots it and it's beautiful. But if you want to use another method, I think Open 3D library is a really good alternative. It it's it's I think it developed for this kind of data representation, point cloud, voxels, octrees. It covers all and it supports all of them. So if you want to have another way to visualize your file, I think Open3D would be good alternative. But if you have just a small files you want to take a look in Python, matplotlib is enough if your file resolution is not that high. So we're done with visualization. Okay, let's go to the last step, which is if you have multiple files. So if you have multiple files, let me delete the last, okay, the code. So we have multiple STL file here, and we want to turn them to voxel. If you want to go to the previous method, which using command prompt, you have to write this code, this one, for all of these files, which is not really a smart way to do it. So we can use Python. Just tell it, go through these STL models, read the names, and then we use subprocess to use similar things, similar code that we use in Sim with command prompt. We use it here, say Binvox, dimension 32, exact voxelization, output Binvox, and then input file name, which is in this code, it loops through, reads the file name, and run this code for every file. And the other thing that you have to look is that this Binvox code or command does not support for you to specify the output directory after you turn the 3D model like STL to Binvox. So here you can again use Python to just after you created a file, which creates it in the same directory of your input file, and then you can just move your voxel to another folder. So it's really easier to create a data set. I think that's the code. I put this code as well. I created GitHub repository and put all the code there and put a link in the description of the video so you can take a look. Okay, let's try it. Let's try this code. This code is here. We have our Binvox. So we go to command prompt. We just type Python converter dot py. Okay, you can see that the file were converted and then moved. They were converted here. STL were converted here. The Binvox was here, and then Binvox was moved to the output directory, which is a voxel file. We have all the voxel 5 file here. So I think that was good for this video. In the next video, I will talk about how to create a lot of data set, a lot of these STL file using FreeCAD. So stay tuned and thank you.